Hello everyone. As you may know, I'm developing a set of videos about architecture and what is the role of the architect in all the areas around the software project. And when I was developing the third video for this series, I started to wonder maybe it's a good idea to present, let's say, a whole picture about what the architect's involvement in all the processes before continuing to show more technical things. So the video that I want to present you today, it could have been the first one, but could also be the latest one. But I decided to present it now so you have a kind of a whole picture about what are the main activities of an architect in the several phases of the project. And you can see here pre-coding, problem framing, interactive architecture, and prototyping, something that I know that I already talked about in previous video, but it was just information that I gave. But I think a map or a path about the architect could be a good idea, and that's why I created this video. Again, it could have been the 01 or the first one, and also it could be the latest one, but I will present as the third one. But you will see in my thumbnail that will be part 0, not part 3 or episode 0 and not episode 3, because it's like when you are, let's say, create an agenda to explain something, and this is the phase. It will be the agenda of the daily work of an architect, since the pre-coding phase, discovery and framing, until architect leadership and mentoring, right after the ongoing architecture evolution. It means that the product was already deployed, and now you are still working in your company, and what makes sure that things are working great, and you have new members that you want to teach and take this project so you can move to other projects and just be a kind of a mentor or someone that is monitoring closely these projects, but you don't need to be really involved with them because they are well deployed. And maybe some junior architects or maybe software engineers or developers are really motivated to be architects, to take the ownership of them and with your guidance to move forward on those projects. So again, I would just want to present this. If you want to understand the step-by-step approach for each one of the phase, what is the involvement of the architect, please follow this video. I will not go too deep again because it was just an introductory. There is no specific path and set of steps to be an architect. I will create a lot of videos about it, and I hope that during this process you start to understand better what is to be an architect and if you really want to be one. Okay. So let's start with the introduction to architect's role. So what are architects? They are visionaries, and it's one of the most important things because they expect the architect to have a kind of a vision how to implement this, what will be the involvement of all people, what will be the constraints, what will be the dangers to avoid, the traps and things like that. So ensure that the system aligns with business goals. So usual business people, where's the architect? And okay, do you have a solution for this? What will be the product that you are proposing? What we will do about this requirement that we have? We need 1 million users by day in our website. What is your proposal? Cloud, data center, this product, another product, which database will you use? It will always look to you to take this decision. So they expect you for you to be a visionary, and visionary in the sense that you should look into the future. What can change in the future? What if the users increase? What if I want to plug more features on the system? Maybe I want to integrate to the legacy system. Maybe I want to partnership with other companies, and everything, it will be important. So they will always look at you. So even if you are a kind of an introvert or more shy, let's say you are not the, let's say, a people's front that really like to talk, you are more introvert and not extrovert, but you will be the center of the decisions. People will look into you. Okay. So make trade-offs between business requirements, technology, time, and budget. These are usual constraints, and you can only take a decision when you see this. So you have the business requirements, you have technology that you can use, and then a lot of things that you have to think about. It's not, you will not choose the best technologies because maybe you have constraints on time, meaning the budget, and maybe you have even constraints on time that will not allow you to learn or hire people to do that. So there is always these vectors always against you that you have to take them, embrace them, and take good decisions on it. And it should be clear for you. You must be very clear about your choice and about your decisions. You always have to explain why are you taking that decision, and if you want a tip, that decision that you are taking, try to be aligned with business requirements and the interests of the company, not in the interests of technology or on your interest because you you have a kind of great knowledge about a specific technology. Being an architect is about being a nice guy to the company and their interests, not yours. Okay, you had your time to prove your technical skills in development, software engineering, and things like that. In architect, they still want you to do that, but for their interests. Of course, you can always argue as a developer, you should also target the best interests of the company, of course. And but if you want to see more about the difference between developers and architects, I already created a video about it that you can check in my series. So architects as decision makers make high-level technical decisions, of course, guide the development process to ensure technical integrity. This is really important. There's sometimes people see that, okay, the architect is the guy that will create a blueprint and a set of rules and people will follow it. How do you know they will follow it? You have to be on them. We have to create ways, not to micromanagement. It's not a good thing. People don't like to be to have someone always over their shoulder, but try to create a kind of a checkpoints or ways to validate if people are really following your decisions. It's not that you are paranoid. You remember that your interest is for your company and you have constraints that sometimes people, developers don't understand. When I talk with developers, they don't understand the budget restrictions. They understand, of course, what is a constraint on the budget, but they don't understand, okay, but this is the best technology. This is the best way to develop. Why can't I do it like this? Well, the architect knows, and it's not because he's the architect and is imposing as authority. It's because he's, let's say, takes some care about the business interests. So architect as communicators, this sometimes is a challenge because from my experience, usually people that are really very good at technical, let's say on the technical side, they are usually not very well good communicators because it's a kind of a clash between introversion and extroversion. People can argue that what I'm saying, that's not true, but usually people more extrovert, they are more associated with social skills. They talk like politicians, people that really like to sales, business leaders and things like that. People that really love to talk with other people, to be in conflict, to talk them, to sell and things like that. And usually the people more associated with engineering, developing, even architects, sometimes they like to work alone. Maybe they don't might work with people and in collaboration to get best results, but they like their own time, sit, put some phones, listen to music when they are working. Maybe I'm mistaken about this, but my experience says that with a lot of teams where I was. So sometimes it's a challenge to the architects being communicators. But if that's the case, try to take some course, learn to be it, try to check inside of you what is, let's say, blocking you to be a better communicator. I can speak for myself. I was not a communicator. Something that helped me was to teach people. I was a trainer for some time. Sometimes I am still training. I create meetings. I teach something to people, and this can help you to be a better communicator. Okay? That's just an advice if you have that issue. So embrace it. If you feel it, don't lie to yourself. Say, no, I'm a great. If I want to. I can be a great communicator. No, you can't. If you think you are not, if you are not now, it doesn't mean that you. Maybe you can. But don't lie to yourself. Maybe you need a process to reach there. And if you are honest to yourself, you can improve yourself. You can compare yourself today and yourself tomorrow. If you think that you already are, you don't improve nothing. That's sometimes people they have a kind of an ego, and this ego blocks themselves. So be careful with that. It's just an advice that I'm giving to you, and I speak for myself. Okay, I know what I'm talking about. Okay. So architects as communicators interface with stakeholders. Of course, all stakeholders are important in architecture. Development teams, external parties. This one, it's when you are really more at level at engineering or enterprise architect, you start to talk and make business and contracts with external companies. You decide if it's more important, let's say, if it's best to hire an external company than to build inside, and you have to take business, and you are almost a manager. Okay, there is a kind of, we can say that there are some levels of architecture. You kind of a software architect, application architect, at some point to reach enterprise architecture. But sometimes there are these architect that it's an enterprise, but it can go business also. It's a little bit different, but usually it's more when you start to do business with external companies and you're taking great decisions about it. You are close to enterprise architect. That's the difference between software architect, application architect, or whatever name people are giving today, and the enterprise architect. The enterprise architect is someone that is like it's like is the owner of the the company, but from the technical point of view. And that's why I return again to the architects as visionaries, architects as decision makers. So again, it's in your interest to be zealous about the interests of your company, because you will be creating or making business with external parties. So you want the best interest for your company, not your own interest. So, and then translate business requirements into technical solutions. That's the definition of being an architect at the end of the day. So let's see, this is just a graphic to demonstrate that text. I don't like to create presentations with only text. I think sometimes people are visual, and I think it's something that I invite you to do. Try to be visual about the things that you explain. If you are to be an architect, people like to see diagrams and the flow of things. They memorize and understand faster than just reading stuff. Reading stuff is just too much abstraction, but when you see it, you say, okay, so I have external partners, okay, so shared needs and compliance, coordinate solutions, and sometimes even they do business. Of course, they need agreement from the sales department of the company. You have also the business stakeholders, executives, project managers, and things like that. So you can define the goals and constraints, and you align the vision and strategy. In this business, of course, there is also the owner of your company or the people that are taking business decisions on it. And then, of course, you have the development teams, engineers, quality assurance, DevOps, and things like that you want to follow, because you develop the project, and it will be one of the things that I will explain in this video, is that, okay, you have to be always on them to check what is the current status of development. They are following your technical guidelines, but then there you have the tests. You want to make sure that the right tests are chosen. So again, you are with them, and then later when it is the player, of course, you want to follow with the DevOps team. But we will see more about this in a moment. So let's start with our first phase, which is pre-coding. You can see it from the developer point of view. We are kind of associating developing an architect as developing an application. At the end of the day, it's kind of pre-coding, and in this case, it's just about discovery and framing. So sometimes you have an idea and you want to accomplish this idea, and you start to explore things. You have to try to discover the best solution, products, strategies, algorithms, people, partnerships, everything that can help us to achieve our goals. So you have the business and technical discovery, meaning that we engage with stakeholders to gather functional and non-functional requirements. Functional, of course, it's the business, but usually the most important, not that they replace the others, it's a non-functional, because you can say, I want to have a task management system. That's one thing. Okay, I can develop it. Well, but I expect 1 million users a day. That is completely different development. It's not the same development. Maybe you even want to choose the right language, the right framework, and things like that. And at some point, I assure you that you will take more time deciding these kind of things, new functional requirements than the functional requirements. Because the functional requirements is quite easy. You can create a task, you can assign to someone, maybe you can include in a project, maybe you have a start and end date, maybe you have a due date, maybe you want to put some weight on the task or something like that, what will be the size of the fields. That it's not something new. Any developer can do that. But now, depending on the number of users that I want, if I want to distribute all over the world, in countries that they have some protected data, in countries that they are close to the other parts of the world, maybe I want to reach there, which means that probably I have to put my application should be able to deploy in different clouds and things like that. Okay, and if you are seeing, for instance, my videos about Spring Boot, I talk with something that is called conditional bins, where you can check which code should be available depending on the cloud and things like that. Okay, so this is the business and technical discovery. Conduce risk assessments and identify constraints. Constraints is the most important thing in architecture. You always take decisions with constraints. What can't I do? That's usually most of the decisions are, and it's not that you know clearly. I remember that I was involved in a project that I want to create some authentication, and I want to single sign-on with current authentication mechanisms that already exist in the projects. And that was a problem, because they have some constraints that I didn't want them. It will make my life harder, and it will conditionate my architecture, because depending on the experience that you have, probably some of you already know that an architecture or a solution is as strong as the weakest elements on the architecture. It's because the weakest element will define the maximum level of your architecture. You can have great servers, but if somehow these servers have to connect to something that is weak, it will weak, let's say, their performance. That's always a problem. It's like a group of people. It's in every place. You have a department, you have someone that it's not as strong as the others. Unless you segregate that person, if you are taking decisions with them, you are always trading off somehow. You always have to manage that. It's not trying to put someone over other people, but that's life. It's like if you have a rope or a chain, if you have a weakest link there, you can have strong ones. The other ones, you have 99 strong, let's say, in the chain links, but one is weak, it will break on that part. That's the truth of life. And of course, document business needs and translate them in technical specifications. This is the common thing that they expect in the first phase of an architect. Then you have technical feasibility study, meaning, okay, is it possible to implement like this? And this is, I'm doing this all the time. Evaluate existing solutions or technologies and identify potential technical challenges such as integration with legacy systems or scalability requirements. This is the daily thing on architecture. Okay, and then architecture vision, of course, define an architecture blueprint. So you start with a draft, you do a design, okay, and then you try to ensure alignment between business objectives and technical design. Meaning that when you do this blueprint, you want to show, first, don't do it too technical, the blueprint, because you'll present to business people. So general box, say, okay, this model communicates with this one and it's secure. Don't say, okay, I'm using TLS version 1 or something. They don't care about that. Just tell them, okay, it's safe, it's secure here. Okay, we can trust this. The data is protected because we have this. This is the alignment that you want to show. So you should have different diagrams. You have a diagram more application and you have one more technical. For instance, if you use Archimate and TOGAF frameworks, on the Archimate, which is a language to design architecture, you see that you have a layer about application where you say, I'm using a word processor, for instance. And then behind the scenes on the technical part, you say, okay, this word processor, which will be, for instance, Microsoft Word or Google Docs or whatever. Then you specify technically what you really want about that. So you present the application to the business and the technical to the technical people on your company. So again, if you are a visual person, this is one way to represent that information. So you have the business stakeholders. This is the line about the stakeholders. So we engage with stakeholders, executives, project managers, and users. You gather requirements with them. Then it's on your side to conduct risk and constraint assessment. You check the feasibility, the technical one. It's possible or not. It's not. Okay, you have to reframe the scope or just requirement to check, okay, it's not possible because of this. So we have to reassess the risks and viability and return again to the stakeholders. If it's possible, you define the architecture vision, not the solution. And I say, okay, I expect the architect to be implemented like this. And the vision, it's more than just one diagram. I remember developing and discussing with other architects the architecture vision. Sometimes it's the document that say, this is the first version of our architect. And usually, sometimes the people call it plateau. And then you have the second version. Okay, it will be like this, but we want to our final architect will be this third one, and this will be accomplished in 1 year and a half. On the first 6 months, we'll implement like this, and due to these things that we are introducing, we can then migrate to version 2 without breaking nothing, and then on the third version, we'll do something like this. And we are doing this because the company only has this money. We expect this number of users to later pay or allow us to increment the budget. There are a lot of things, a lot of decisions that we'll taking into consideration what I said previously about the budget, time, people that you have, technology, things like that. It's quite common. This is the architecture vision. It's not the solution. Okay. And then, of course, outline key components and strategy. If you already create the vision and it's accepted, you can say, okay, these will be our main components. You'll be using, let's say, AWS or Azure. You'll be using the Cosmos database or any other database or Postgres database or DynamoDB or other, and the strategy will be like this one. But I will address most of these things that we are seeing here in different videos later. So now we have problem framing and architect design on the second phase. So we frame the problem, break down complex business problems into manageable technical challenges. Sometimes I remember once I was in a meeting with Microsoft and we were doing a kind of brainstorm, and I really liked their approach. It was a lot of years ago. I was starting to be an architect, but I really love the way they present things. They have a big wall in a room. It's a kind of a glass. And when we start to talk, there was some kind of a knowns that you talk about people, customers, and they just draw boxes there. And they didn't try to create the architect. They just put the boxes. And every time you say authentication, okay, we'll need authentication systems. So put authentication, authorization, things. And then we look at all the boxes and we start to reflect on them and say, okay, this is business. This is quite interesting. And the responsibility of this box will be like this one. So we start to break down something that was complex in small parts. And then we exclude the ones that didn't have any behavior. And the ones that were there after, at the end, there will be the components already break it from the system, okay? So define core component services, subsystems that need to be developed. And here, of course, you have some ranking. There are some of the systems are more important than the others. For instance, authentication probably it will be the most important, and usually most of the proof of concept start with this one. Even one of these days I was developing testing an application, to automate. It was very difficult to test the application, but I start to have an idea how to work around it. And the first thing that I tried was to automate login. And why? Because the login was integrated with Microsoft. So it was a kind of a mobile application, and inside there was something that I didn't control. It was a web view. I didn't have access to the web view, and I was trying to automate that. I succeed using some tricks under the device of Android, but it was really quite challenge. Stakeholder alignment, again, organize meetings with product managers, business analysts, developers, gather feedback and align expectations to ensure architecture will meet both short-term and long-term goals. Again, something that I said previously, sometimes architecture vision is not the solution. Your solution can be multiple solutions. You have a short-term one and then you have a long-term one. Sometimes it's not possible to implement everything. So at the end of the day, architecture is about changing, evolution, and you must follow, and probably it will be one of the latest phases that we have here. So high-level design and conceptualization, choose architecture styles. Now you are doing this. Should you go microservice, monolith, serverless, and define the system's high-level structure? Don't fall on the trap to say microservice is a trend, I will use it. I have a video about that. It's in my series about decisions framework, where in the first principles, I think, where I talk, maybe sometimes you have a microservice, it's a good solution, technical, if you are developing multiple mods. But maybe you shouldn't start with that. Maybe you don't have people, budget, and knowledge to do that. Because microservices can start to be really complicated to manage, let's say in 6 months or 9 months. It requires a kind of, let's say, DDD culture, domain-driven development culture that understands what are the domains. They don't mind to duplicate data and things like that. And sometimes it's better for you to start, for instance, monolith, and then move, if it's necessary, to microservices. It's just a tip. I'm not saying that it's always like that, but don't, again, fall on the trap that, okay, this is the best, everyone use it. Don't go there. Start with, check my video about the first principles on decision frameworks, and you understand. Be true about everything, about the constraints in your company, and take decisions from there. Don't take decisions about what if, no, not what if, what do I have? Okay, if I have a car that only runs maximum 100 kilometers, I don't want to enter in a race where I have cars that can reach 200 kilometers hour. Okay, so you understand what I'm saying. So outline key technical components such as database, APIs, and security measures. Start to decide or start to wonder, maybe I should use this database or this database. Something that usually I recurrently discuss with other architects and senior people. Okay, what is the best database? Which one should we use? Maybe this one was the best, but we don't have the knowledge. This one, it's not as powerful. This one, but it serves the purpose. That is okay. It's not the best one, but yeah, it serves. It's cheaper. We understand it. We have experience on it. The community is big. Why not? And then you have defined system interface and integrations. And usually this one, it's a really challenge. Okay, the integrations, and I'm sure I will provide us a lot of videos about integration. And again, so you have stakeholders, they start with the business domain core system, you decompose your problem, okay, in small parts, then you have the architecture vision. Only you have, after the break, you can have the architecture vision. Again, architecture vision, it's not a solution from the technical point of view, it's more from the long term, it's a kind of a plan of a strategy that we want to use. And sometimes you can create, let's say, tactical decisions. Meaning I have this first version, then second version, third version, and I will reach the architecture in 1 year or 2 years, but we can start with this safely. But usually on the architecture vision, you approach, this is the most probably 5 components. I'm sure that I'm missing some of them here, but core components, you want to define my application needs these components. APIs interface, how am I exposing or integrating with other systems? I'll make sure that the data is safe from any user or other systems. Integration points, how do I integrate to the other applications, for instance, internally or externally, and non-functional requirements. How am I handling the scalability and things like that, logging, audit, metrics, telemetry, and things like that. Okay, and then the core components, of course, what are the subsystems and service, and the data layer, which even if it's a small box here, probably it's most important in the current days, as you know. So by this time, we already know what we want to develop. We already have components, everything that we saw here, right? We have core components, APIs, security, integration points, non-functional requirements. You have an idea of what we want, but we are not sure that we know if it's possible to accomplish or not, and how can we accomplish these things. So we need some kind of iterative process to make sure that it's feasible or not. What are the constraints, the limitations? We went to gather some evidence about, yes, we can do it, no, we can do it, or maybe we can do it with all these trade-offs. Again, one of the most important words in architecture, right after the why. So we start with architecture iteration. So architecture, it's not static. It's not something we design and that's it. Due to all the constraints, most of them, they are not technical. Sometimes it's necessary to be changed. So it should evolve based on new information and feedback. And we are always gather new information. Some of them from stakeholders. Other times, others are done by metrics, surveys, and things like that. So release smaller architecture prototypes like proof of concept to test assumptions. So you say, okay, maybe you should authenticate like this when we integrate the system. So let's do a proof of concept to make sure that it works. Not later. We never assume nothing unless you can prove it. Okay, really try it. If it's a question, if there are even a small doubt about it, do a proof of concept and show. It will give you trust. You even from that you can take some lessons learned, challenge to the testers. Maybe you have to discuss something with the business to say, okay, we can do it like this, but it doesn't seem right. I don't know if we want to go with the person's email or with a username, because inside of our application, maybe this person can have multiple emails for some reason, because there are multiple systems, and in some of the systems, this person is already registered when we are integrated. So there are always, we need this proof of concept to get some lessons learned. So, and then we iterate on designs based on testing, business needs, and new technology discoveries, because again, the lessons learned. Every time we are doing something, we discover information. So always start with a proof of concept. Take it personally. You don't have to formalize or something like that. Sometimes you have to involve other people. Most of the times what I do is just start myself. Take 1, 2, 3 or 4 days, sometimes a week. And I try to develop that. And I create some assumptions for me. I create requirements. I develop a lot of what if, and test it and say, okay, now I'm ready to present this solution to the stakeholders. Then experimenting with technologies, of course, this belongs to when we are developing this architect interaction. So explore new technologies, NoSQL database, cloud services, containerization. Should we use Kubernetes or not? Maybe it's too complicated at this time. Maybe in the first version, we don't go with Kubernetes, just simple Docker, or maybe you use AC2, if I'm not mistaken, containers in AWS, or container apps in Azure and things like that. Evaluate the feasibility and fit of new tools through small proof of concepts and internal assessments. Okay, it's following what we have been said here. So stakeholder feedback loops. That's important because regularly meet with stakeholders to validate architecture decisions because you need their approval. They don't expect to validate your technical solution, but they want to make sure that the solution you are proposing is aligned with their business requirements. And again, business requirements is not only about functionality, even money, budget, and other things belong to this alignment. And use feedback to refine architectural choice, especially in uncertain areas like authentication, scalability, and things like that. So again, if you are more a visual person, you can pause and check this, but this is just a step-by-step approach after what I said. So we export technologies, build a prototype, test the prototype, conduct stakeholder meeting. After you test it, take some lessons learned, create a document, a diagram, explain, maybe take one or two the critical use cases or based on a risk approach. This use case has the most impact in the solution, so we'll test a proof of concept with it. Then gather stakeholder feedback. Okay, if everything okay, great. If it's not, refine architecture design, build prototype again, all and not satisfy the stakeholders. Okay, let's do it again until we reach a point. Usually these take maybe 2-3 iterations, no more than that. If it's more than that, I think you are losing time. Maybe someone should decide, okay, don't develop this project, just decide something, create a kind of, I have a video about this, it's a decision framework called time box. Just create a time box and say, okay, in 1 month we should have a decision. Maybe we can analyze every week and we will promise to each other that after 1 month we have a final decision and it should be a go or a no go. But do that, otherwise it will never stop and you are not spending money on the project, but you are spending money on the people to think about the project that maybe will not go forward, so you spend money for nothing. So establish limits, use for instance a time box approach, and when they are satisfied, just document and finalize the architecture. Finalize, let's say, the first version. Maybe an architecture, it's never finalized. Then you have the fourth step, which is development phase. So now we decided there was some approval. Now let's start to implement it. So ongoing architecture oversight. So assure that the development teams are following the guidelines that you created in the document. And sometimes these guidelines is just not nice to have. It's something you should use this protocol. These secrets should be kept in a vault, for instance, things like that. They should be on this cloud. We should use this database or these two database. This database only exists only for read only. It works as a kind of a cache. The other one is for management, so accepts inserts, updates, and deletes and things like that. It is even there is even a pattern that follows this approach. So this is the guidelines. Don't say guidelines is just okay. It's good for a method to not have more than 3 or 4 parameters. Okay, it's a nice guideline. But I'm not talking about these guidelines, although they are important, but the guidelines for the architecture, and make sure that you are enforcing these guidelines, these decisions, okay? Review code, designs, documentation to ensure consistency and maintainability. That's a review code, it's always a good idea. It's a very polite way to check if the people are doing in the way that you think it should be done. Because you want to review code, it's not that you are saying, okay, I don't trust the guys. You trust the guys, but what you probably don't trust if they understood well what you said and your explanation. Because if they are following a document, mistakes can be made on the interpretation of the document. So don't be afraid to say, I want to review how things are done, not because I don't trust you guys, but first, I don't trust myself to provide the best solution to everyone, because I don't want to enter into philosophical arguments, but each one of the person in the world sees the world differently. And when you have a document, if you try to ask 2-3 people how they interpret the document, you will be surprised. I hope not, but maybe you will be surprised if they give you 3 different explanations of the same thing. So it's not about trusting people, it's about trusting the way we work each other and how we see the world and what the world provides us. In this case, documents, guidelines, and things like that. Design patterns and refactorings is really important for the architecture. You should always have a kind of reference architecture and patterns that the team should follow. For instance, for logins and the way they connect to database, try to document these things and provide to them so they have a kind of a formula to use. And if they follow these patterns, you are sure that these guidelines are being applied somehow, at least a biggest percentage of it. So promote user or proven design patterns. From the point of view, I put this, but maybe some of you are not architecture, but factory, singleton, observer are usual patterns from development point of view. Software engineering, when you start to go to architecture, you start to see other kind of patterns like circuit breaker and other kinds of patterns, but make sure that they use them when they should use them. Of course, don't use them because they are patterns. Otherwise, you'll start to be in the anti-pattern space. So refactor code as necessary to adhere to architecture principles. These principles should be written, defined, and clear to everyone with a place people can read and can ask questions about it. Maybe it's a good idea to create, let's say, monthly meetings or something with 1 hour to explain if you change something on this documentation, explain what you mean by your documentation that should be followed by the teams. Maybe it's a good thing to do. And address bottlenecks or inefficient designs during development sprints, meaning test things. Make sure that you can find the bottlenecks because they will be a bottleneck, right? And you don't want that on your application. And bottlenecks can only you can have them from the technical point of view, and sometimes even on management. Sometimes it happens. I remember that in some teams, sometimes there is a guy that knows everything. He assumes all the responsibilities. There are several reasons for that. Avoid that also. Try to distribute the work. If someone needs training, train the person, explain, sit with the person, teach that person to take a subject and don't, okay, we have an expert guy, so we will do it. I don't like meetings when someone says, I will do that in these 2 sprints. That's not the idea. The idea is to be as a team. If the other members don't know how to do it, maybe you should teach them unless they belong to a different role. But if they are developers, if some of them need training, okay, let's do training. So we have kind of a redundancy on the teams. And redundancy on the teams is as important as redundant on architecture solutions. And integration planning, ensure all subsystem databases are integrated smoothly, of course, only with testing and good planning, and all inter-service communication, data consistency, and failure recovery. This is things that happen that are addressed at the architecture level. Here are just information. I will not explain each one of them because I'm sure that I will have videos for each one of these things that I'm saying here. Okay. So again, you have the architect, you handle the relation of developers, DevOps. There are other people that you can put here, but since we are on the development phase, I just put here the developer and DevOps. The developer because you want to check how the developing is being done, if it's aligned with what you expect, but you have to also to talk with the DevOps to prepare the operations, to prepare the environments, to prepare the technical requirements for the application that is been developed. You don't finish the development, then you have DevOps. DevOps starts earlier. Maybe at a point when you have a Git and you are committing things and you are producing release. Now what happens? What will be the delivery? To where? What will be the strategy? When we have multiple deliveries, how you handle this? We have to wait until one is delivered before starting the new one, or you can start in parallel. How do we collect metrics on this? How do you gather them? How do you interpret them? Who will be responsible for this? Who will be responsible to give support? Do we have people that understand the application, that understand this technology? How the logs should be created so the DevOps can understand the logs, extract information and provide alerts. There are a lot of things that are really important to talk with DevOps even before the first release of the application. So don't forget it. Testing and refining and performance. So everything now it's somehow developed, let's say like that, at least the first version. So yeah, of course, we need quality assurance and testing, create test plans and strategies, special for larger critical components. It's not that you have to create a test plan. Maybe you have a quality team to do that, and I hope so. But as an architect, it's your responsibility to tell them which tests are the most important. I need a load testing because scalability is quite important. Let's start with, let's say, 10,000 users. What happens when you go to 2,000? Can you give me the number that where it will start to have a bottleneck or the latency starts to increase and things like that? So you want to talk with the teams, the test teams about that. You have to sync with them. And these reports that they will provide you will be good and they should be presented also to the business. You say, okay, we can handle this. if we want to handle more users, we need to use a different technology. Again, this can happen in a specific cloud, and this will cost us much more money, for instance. Okay, so work closely with the testing teams to ensure thorough coverage of system functionality and architecture. Then stress testing, it's and performance tuning. Of course, security architecture review. This is one of the most important nowadays. Identify security threats. There are tools to do that, but make sure that the developers or talk with the people that are, let's say, managing the developers, that they are using specific frameworks, for instance, to avoid concatenation of strings, to avoid SQL injection, cross-site scripting. Of course, maybe propose if you don't have tools to help to identify these kind of things. And there are a lot of tools nowadays, even some of them using artificial intelligence, that can try to find issues and bugs in your application. And consult with security experts to ensure compliance with best practices. I once worked in a company, I was an enterprise architect there, and there were also other enterprise architects just dedicated to security. And they were completely paranoid, but I learned a lot from them. Things that sometimes it weren't clear for me why they were important, and they start to explain to me why something was important on my decisions that could lead later to a kind of a hole that could be explored, not technical, but socially by anyone on the system. It is quite interesting to talk with these people. Sometimes it's difficult because they have a different view perspective on the system. They are trying to think as hackers, and sometimes you don't understand. It seems too paranoid, but it's only paranoid until, let's say, there is an attack and our system fails. Then it's not paranoid. We will feel bad about it. Okay, so don't be afraid to talk with them. Try to learn a little bit about security as much as you can, but there are things that should be really reviewed by security. Security per se, it's a completely architecture and a completely area by itself with a lot of subjects to handle. So again, a more visual approach. So we have create test plans and strategies, run the tests. There are issues, no, great. We can release and maybe we'll start the next iteration of architecture. Yes, analyze bottlenecks, security risks, optimize the system, issues found, and again, in cycle. It's just a visual representation of what we said. It's always nice to see some boxes and not only text. Okay, deployment and post-deployment review. Okay, now it's testing, now we want to deploy. So how ready is to deployment? So assure the system is ready for production by reviewing deployment procedures, CI/CD pipelines, and infrastructure. I would say that it's not at this phase. You already start this on previous. You decide about that. You have DevOps team. You start to talk with them. But at this time, you'll be serious. Make sure that it's really ready before you deploy the application. And plan for disaster recovery and backup procedures. This backup, it's quite important because once I was a trainer of databases. I really like data. I never worked as a DBA administrator, but I can teach DBAs in a lot of things. And because I study a lot in data, it's an area that I really like. And one of the things that was surprised me was when I told them that you should test your backups. Because sometimes people do a backup, but they don't test the backup. They just trust the tool. And I remember that I work in a bank, and they had a tool that the backup took almost 6 hours or something like that. And then the restore will take a little bit more because usually the writing is slower than the reading. And they had a problem. And when they start to restore, the restore did nothing. Nothing happened. And they discovered that the tool had an issue, that he backups everything, but it wasn't writing the data. It was just crazy. It was a bug. And they didn't know about it. It's a completely crazy story, but I can assure it was true. So from that point, they could use other backups and other strategies that they use, because apart from the backup, they have a different strategy, was to log shipping the database, meaning that they were doing backups, but every 2 minutes, every change in a database was published to a different database in the other side. They have a kind of a redundancy, so they could let's say, recover with that information. But starting from that, every time they did a backup, every Saturday they did a restore and make sure that the data was different and the backup were working. So always plan for disaster recovery and backup procedures. It's not backup procedure. It's not okay. We'll do a backup. No, a backup procedure is it's a process. You want to back up and you want to test the backup somehow. Usually people take the production and restore in a pre-production, so I have a kind of an environment that where they can test with real information. But of course there are some issues when you are using GDPR and other data privacy things, but it's a strategy. Then you have continuous monitoring and improvement. Of course, you want to monitor your application. I have a set of videos that I'm developing, or some of them already deployed, about telemetry, observability. It's something that you should take care nowadays because systems are quite complex and you want to understand what's happening inside. If you are not seeing my videos, please do it. Study about observability, but at the end of the day, make sure your application can produce metrics, logs, and trace. Just a tip that I can give you, and you can start from that to understand what observability is. By the way, Prometheus is great to create metrics and alerts, and Grafana is a quite nice dashboard. Of course, these two systems don't handle the system monitoring. You need more than that. You have to collect them. You have to prepare your code for that. You have to choose a technology or maybe a framework that can facilitate this to you. There are a lot of things that you have to think about before reaching the phase of the deployment. Meaning that an architect, if you read again the slides that I'm explaining here, always has a long-term vision. So when it starts the architecture vision on the first slides, is already thinking about this also. So the application should be ready for that. Okay. Assess system performance in the live environment and adjust as needed. Okay. This is meaning observability. Post-deployment architecture review, meaning after deployment, ensure the system meets the business needs and technical expectations. Sometimes we test, we develop, and when it's in production, okay, it doesn't seem to be working as I expected. Even this integration, the partner forgot to say this to me. Okay, it said it was just once a day, but it's sending information every hour. I didn't account that on my diagrams. These things can happen, but you have to monitor them. You have to be ready for them, and you have to understand how to adapt to these situations. Okay, conduct regular reviews of the architecture for potential improvements. Database scaling, Microsoft's performance. Of course, you need metrics. You start to collect what is the growth of my database, the number of requests, the logins, the attacks that I have, a lot of things that you have. But for that, of course, you need continuous monitoring to help you to do a good architecture review. Again, from the deployment point of view, you review the deployment procedures, you deploy to production. Then you have this big blue area, which is what happens when the system is running. So you monitor the system. Again, this is just an example, Prometheus and Grafana. There are other systems that you have to include. If you want to know more about that, at least from an observability point of view, I'm creating a set of videos about it. You can check them. I'm going to detail. I already provide one video that I explain everything with an architecture, but in later videos I will show how to implement in some applications in real. I will really show you Prometheus running, Grafana, or Open Collector, Open Telemetry, things like that. So the issues were detected? No? Okay, I will calendar another review maybe in 1 or 2 weeks, unless an alert makes me return to the application. If I found issues, okay, fix and tune the systems, review what should be reviewed, fix the bugs, and this happens a lot. It will be very difficult to not have issues. There are always issues one way or another, but some of them are critical, other ones sometimes you can just pass for a while. And then again, you start to monitor the system. Again, you are on this cycle. So issues detected, and okay, architecture review, post-deployment review, assess if system needs business and technical goals, and things like that. I think it's quite intuitive when you understand the whole cycle of the software development. So, and then point 7, ongoing architecture evolution. Now you deploy your first version. Things will not finish here. Things will change, users will change, requirements will change. You start to have some lessons learned, and even stakeholders, they say, okay, I would like to have this feature now. I don't want this feature. I want to do an A/B testing. I want to create a different dashboard, but I don't want to break the current system. I want to know something about the user, if they like it or not. And maybe we create a beta dashboard. You start to do some A/B testing. A/B testing is when you have, let's say, kind of a feature toggle, meaning that sometimes you activate for specific users or other criteria a different approach on your website or application, and you see if people like it or not. And you know that people like it if they use it and they go to the end. If they just go back and try to use a different approach, maybe they don't like it, so you don't want to use it. You will not introduce on the next version. That's the A/B testing. So continuous feedback loop, monitor system usage, collect feedback from end user stakeholders, use metrics again to continuously assess the system, future proofing, look ahead for potential scalability issues. So you see the trend lines and say, okay, this is the traffic in my website, the way there are some pages or some parts of the system that are never used. The users, they don't came here. Why? And you want to know about that. So you want to check what's happening on your system, if you want to improve it or not, and take decisions from that information. Stay updated on emerging technologies. Check if a technology is appearing that can, for instance, replace part of your system, or maybe fix some, let's say, something that it's weak on your system, but it was a trade-off that you had to do. And now there is a trend that say, okay, this seems that this product can handle better what you have accomplished. That okay, start to plan, maybe again do a proof of concept, follow all the stages, talk with the stakeholders, explain to them why it's better this new approach. Maybe they will spare money on it. How it's not that the money can be, maybe you need less people troubleshooting things, less people on the call center. There are a lot of ways to reduce the budget of a system. It's not only the technical part. And knowledge sharing, you have to share the knowledge and lessons learned with other architects or software engineers, even development teams, and a broader community in your application, even stakeholders. You have to share some of the lessons learned, and conduct retrospectives to identify architectural pain points and the areas of improvement, as we were talking about here. Again, these are things that can happen at the same time. You have to start architecture evolution here. So you have a continuous feedback loop here, collect metrics, analyze system performance, continuous something that happens from the monitoring point of view, observability. Of course, you want to check the future by analyzing what you receive here somehow, but you can do at the same time, identify scalability and technology updates, plan for emerging technologies if they are relevant, not because they are emerging, they are good. Okay, and continue future proofing here, and at the same time you have to share some of the knowledge, otherwise you will just get crazy. You cannot have all the responsibility, all the ownership, everything only inside of you. You want to share with other people so you can delegate and start, who knows, another project that your company wants. But you must trust the person or the people that handle the project that was deployed. So share lessons learned, conduct retrospectives, continue on knowledge sharing, and review update architecture strategy. And then we start everything again. Okay. And finally, architectural leadership and mentoring. This is something that I usually try to do this. Sometimes people don't like it, other people like it, but I like to teach people. So it's something that I learned. I once read a book. I think I have it here somehow. I think it's 21 lessons for leadership, something like that. And one of the things that was impressive when I read that book, and I think it's right, is that you are only a good leader if you can train others to be leaders following you. It means that I prefer people that are better than I in the subjects that I'm handling than myself. I want a better test architect. I want a best user interface person than me, because I don't. If they are better than me, I will trust them, and I'm relieved to give the project to them, and I can start to check other things. If something happen, I know that people can handle it. I don't want to handle everything, otherwise there will be a burnout. But sometimes people they don't trust themselves enough in their value to perform in this way or to have this behavior. But sooner or later you will have a burnout if you don't delegate and share your knowledge with other people, and you want to share with people that are best than you in those areas. Of course, you can always say, okay, but if I give to others people all the knowledge, at some time I will be replaceable. You don't have to. You don't want to teach someone to be like you and have all the other information. You can use the CIA if you want something like that. If you are one of these people, techniques which is to compartmentalize information. Just teach to that person what that person needs to know about that subject. You don't need to explain everything. Just keep some of the things to yourself. If you are let's say, if you don't trust yourself enough to be valuable to our company. And I'm sorry to be very straight here, but I have experience, and I have managed, and I have work with a lot of different people, and these things exist. I'm not a kind of a romantic guy that comes here and world is beautiful with a lot of flowers, everyone is nice. No, that's not true. So be careful. Trust with the people that you really want to trust, and don't trust if you smell something that is not right. Just trust the professional part that the person should know. Don't go the other unless maybe within time you look into things and say, okay, I was wrong. These people are trustable people. They are nice people that I'm working on. Okay, I can share more. But okay, just take a precautions on this kind of environments. But I was once took the certification in PMI, and one of the things that I learned that everyone has its own agenda. That's one of the things that you learn when you're a project manager. So you can start from that. But act like everyone is trustable and everyone are good people with the same interest. But be okay. But know how to share the information. So team leadership and mentorship guide teams in making architectural decisions and provide mentorship to junior architects or engineers. It's not that you are training them to be architects, but train at least to handle the system that you develop and understand it. Okay. Foster a culture of learning and improvement within the architectural team. I also work as an enterprise architect with other enterprise architects, and we had that every week or every 2 weeks. Some of us will create a presentation to teach something about it to the other architects. It was quite nice because we grew in the company the knowledge that we can apply in our projects. It was a great thing. It doesn't mean that everything that I knew the other people knew, but some of the subjects that I thought it were interesting for me to know and share with them because it will help them on the other areas of the company. It's that because I didn't want all the projects of the company. That will be crazy and it will make me fail, and that is worse than sharing the knowledge. So always try to balance. If you want everything to you, you will fail for sure. And that is worse than you avoiding to share the knowledge. Okay, there is a lot of things going on. I'll just stop here. This is a completely different business, but at the end of the day, architect is also to be in leadership, and you want to learn how to be a leader. Okay. Stakeholder communication, maintain a balance between technical feasibility and business demands. Of course, something that we talk about here. Regularly update stakeholders on the state of the architecture, risks, and technical depths. You don't want to talk with them about their technical decisions, but you want to assure them, okay, it's working. If something fails, the backup, it's quite fast. We only lose information. I hope not, but we lose this time to recover from the system, things like that. We are accelerating here due to the time constraints. We are creating a technical debt. Later, we'll need 1 or 2 months to put the system with more high quality standards on the code, or maybe you can hire someone just to do that and improve the code while our teams is developing other business things in our application. That's one way to approach this. So again, architect initiates leadership and communication, team leadership, mentorship, guide architectural decisions, mentor junior architects, foster a learning culture. And then you have this continuous mentoring and team support. Again, you are not training people to be like you. You are just making sure that they are good in their areas that are helping you. Okay, don't feel challenged. Don't feel that your position is challenged by them. Just feel that they can complement and make the team work better for the good of the company. And then at the same time, we have stakeholder communication, balance technical feasibility with business needs, update stakeholders and architecture status. Always remember that you are doing things for the stakeholders, not for you. Okay, discuss risk and technical debt again, and ongoing stakeholder engagement. Currently, talk with them. Okay. So in summary, architects' continuous journey, visionary and pragmatic. That's the 2 words that you always have as an architect. Architects balance visionary design with pragmatic real-world constraints. After 3 videos that I think I already created on this series, you should understand this by now. Real-world constraints, it's what its architect is about. Iterative and evolving. The architecture evolves interactively based on constant feedback. Feedback, it's not other person feedback, it's metrics feedback, it's how the system is behaving, what number of bugs and issues you are found. It's everything, any feedback, okay? Performance and business change, guiding the ship. Being architect is being the technical leader. It's making sure that you are not in front of the business people because they support. It's the ones that are creating the business, but you are the, let's say, the beacon that they look for to make sure that you can implement the technical part or the solution part that will bring money to the company or meaning to their interests. So architects are responsible for guiding the direction of the system, making technical decisions and ensuring alignment between technology and business strategy. And thank you for watching this video. Usually I try to put this video with less time as possible, but it's very difficult. I create lessons about how to be an architect, and it's a lot of management and things. I really want to explain this. I'm really trying to reduce the time. Maybe I can split these videos in more videos, but what can I assure you? Probably it's the next ones where I start to be more technical. Maybe I will not reduce the time, but maybe the talking time will be something like 15 or 20 minutes, as I usually do, for instance, for Spring Boot videos. And then the other time will be showing you something technical. Imagine installing something, showing you the metrics, creating alerts, and things like that. That I can assure. But if you arrive after 1 hour of video, thank you for watching. I hope my information was useful for you. I hope that I'm motivating you to be an architect, or maybe I'm clarifying you what an architect is and you say, okay, that's not for me. And I knew a guy once that was like that. The guy was everything to be an architect, but he said to me, I really like to be a software engineering, develop code, create technical decisions. I don't want to talk with anyone. I'm just the guy that give me the project and I will help the team to implement it. And that's it. And sometimes maybe it's your role, and yeah, great for you. If you are happy with that, go for it. So again, thank you for watching my video. I hope to continue and subscribe and share with your friends my channel. So thank you again.